All right, welcome back to pre-calculus. We are looking at problem number 3 on the pretest. We have a nice exponential equation. We have 8e to the 2x minus 2e to the 2x minus 3 is equal to 0. Let's go ahead and sort this thing out. This is a problem that's kind of like, it's a quadratic hidden, it's an exponential hidden inside of a quadratic, because really e to the 2x is really e to the x squared. Remember when the you have an exponent raised to an exponent, we multiply the two of them, this would be e to the 2x. So this is really e to the x squared. So if I made this really easy and I said, okay, let's go ahead and make a substitution. I said, let u is equal to e to the x. We would know, because of the consequence of our choice here, we would know that u squared was equal to e to the 2x. And I said, okay, let's go ahead and solve 8u squared minus 2u minus 3 equals 0. You say, wait a minute. This is a quadratic. We did this in college algebra 1. Like, we don't have to do this. But yeah, it's just a little bit of extra twist on it. Not too bad. So what I'm going to do is something called the AC method in order to factor this. Now, you don't have to do this. You can use quadratic formula, be my guest. But this is how I do it, and I like the AC method. We multiply the first and the last, and we end up with negative 24. Now what I'm going to do is I need two numbers that multiply out to negative 24, but add up to be negative 2. And I think numbers 6 and 4, I think that'll do it for us. Okay, so we can go ahead and say this is negative 6, 4. So we're going to say, okay, this is 8u squared minus 6u plus 4u minus 3 is equal to 0. Negative 6 plus 4, that's going to give me negative 2, so everything works out. Please double check this when you're working on this. Be especially careful when your AC is a multiple of 12, because there's a lot of numbers that can kind of look like they fit but don't actually fit. So just be real careful when this AC is a multiple of 12. All right. So when I'm looking at this, the first thing I notice is that the 6 and the 8, those can pull out a 2. So we'd say this is 2, and I've got a 4u, or 2u, we can pull out a 2u. And I've got a 4u minus 3 here. And then I've got a 1, 4u minus 3 equals 0. Now, since my 4u minus 3's are the same, we can go ahead and factor that through. So we're going to say that's 4 minus 3, 4u minus 3. And then I've got a 2u plus 1 equals 0. Now we can go ahead and solve that. So we have 4u minus 3 equals 0, or 2u plus 1 is equal to 0. At this point, we can go ahead and say 2u equals negative 1. U would be negative 1 half. We have 4u minus 3, so I have 4u equals 3, or u is equal to 3/4. Now, what was u really? U was equal to e to the x. So we have to go back and we have to say e to the x equals 3/4, or e to the x equals negative 1 half. Now, the problem with e to the x equaling negative 1 half is, remember what the graph of e to the x looks like. It looks something like this. Here is where y is equal to negative 1 half. See, here's this line down here. Let's go ahead and make that red. Okay. Now, the thing is that this graph, e to the x, never intersects with a negative number. So this is not a solution that we can actually have. That's got to be a no solution. Okay, that's not going to be counting for a solution. Will e to the x cross over the line y equals 3/4? Like, sure it will. So here's my e to the x. Here is my line, y is equal to 3/4. So if I go ahead and look at that, like, yeah, it does hit there at some point. Exactly where might be a little difficult to tell on my graph, but it does connect. So what we do is like, well, how do we undo an e to the x? We take a logarithm. So we're going to say we want the natural log of e to the x is equal to the natural log of 3/4. And the whole point of doing this was to take this x down to the baseline. So we have x times the natural log of e, which we know, of course, is 1, is equal to the natural log of 3/4. So we could say x equals, and we could do a couple of things. We could say natural log of 3/4, leave it like that, that's fine. And if you want to practice a little bit more with your um, logarithmic properties, you could say this is equal to the natural log of 3 minus the natural log of 4, using, of course, the natural log of a over b is equal to the natural log of a minus the natural log of b. And that's all I did to make that something that I thought was a little bit more pleasant to look at. But That is not necessary. So that's how you solve a problem like that. Um, I guarantee you that the problem you're going to see in your test is going to be something you're going to have to use AC method in order to factor or use quadratic formula. It's up to you. But that is a technique that you will have to use on this particular problem. So if you're get most of the steps, you're like, oh, I need to review AC method. Please review your AC method so that this is not a problem that you're going to struggle with. Okay. So I will see you on the next video. Thank you very much for watching this video. Good luck, everybody.